Assalamualaikum. Now we are going to present about coral reef observation using Sentinel and NOAA AVHR satellites. Now the team consists of Shafiz, Dini and Elise. Importance of coral reef. Coral reef are highly diversified and critical ecosystem. They support marine life, protect coastlines, and benefit human industries like fishing and tourism. Coral reef are threatened by climate change, pollution, overfishing, and destructive fishing practice. Efficient monitoring and management are vital for their survival. Importance of coral reef. Coral reef are highly diversified and critical ecosystem. They support marine life, protect Next, satellite monitoring tools, Sentinel and NOAA AVHR satellites. First, Sentinel satellite, part of the Copernicus program by the European Space Agency. Second, NOAA AVHR, known for providing long-term sea surface temperature SST data, essential for detecting thermal stress leading to coral bleaching. Third, Sentinel-2 offers detailed multispectral image for coral coverage, water condition, and thermal stress monitoring. Next, importance of 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 monitoring. Next, importance. First, climate change monitoring. Coral reef are sensitive to ocean temperature change, acting as climate change indicators. Sentinel and NOAA AVHR provide critical SST data to identify coral bleaching events. This data help understand global warming effect on marine ecosystem and develop mitigation strategies. Next, conservation and management. Accurate and timely data is crucial for effective conservation. Satellite provide high-resolution image and data on reef size and condition changes over time, identifies areas needing immediate intervention, and evaluate conservation efforts. Next, biodiversity preservation. Coral reef enhance global biodiversity by providing habitats for marine species. Satellite observation aids in mapping and monitoring system, ensures preservation of vital habitat and protection of species, promoting overall marine biodiversity. Next, disaster risk reduction. Coral reef protect coastlines from storms and erosion. Satellite data helps assess reef condition and geographic layout, informs coastal planning and disaster risk mitigation. Healthy reef reduce coastal vulnerability, safeguarding human lives and property. Conclusion. Monitoring coral reef using Sentinel and NOAA AVHR satellite is essential for understanding and mitigating the impact of climate change, conserving marine biodiversity, and reducing disaster risk. The integration of satellite data support effective conservation strategies and the preservation of this crucial ecosystem. Conclusion. Monitoring coral reef using Sentinel and NOAA AVHR satellite is essential for understanding and mitigating the
Hello and hi everyone, my name is Dini Sofia binti Sazali, and today I'm going to talk about some challenges we face when observing coral reefs from space using satellites like Sentinel and NOAA AVHRR. The first challenges is data resolution and accuracy. Satellites help us see large areas of the ocean, but sometimes they can't show us the small details we need to see changes in coral reefs. The picture we get from Sentinel and NOAA AVHRR satellites are helpful, but they aren't always clear enough to catch tiny problems in the reefs early on. This can make it hard for scientists and conservationists to react quickly to issues like coral bleaching. The second challenge is cloud cover and atmosphere interference. Cloud and the atmosphere can block the satellite's view, making it hard to get good image of reefs. Just like clouds can block the sun, they can also block the satellite sensors, leading to gaps in the data. This means scientists might not always get a complete picture of what's happening with the coral reefs over time. The third challenge is limitation in funding and resources. Keeping satellites in space and analyzing the data they send back to cost a lot of money. Sometimes there isn't enough funding to keep up regular and thorough observation. This lack of money can slow down our efforts to monitor and protect the reef properly, affecting the plants and policymakers and conservation groups. We move to the next topic, which is the important parameters in coral reef observation using Sentinel and NOAA AVHRR satellites. Let's dive into the key parameters that scientists observe to keep track of coral reef health. First, we have sea surface temperature or SST. SST is crucial because high temperatures can cause coral bleaching, which is harmful for coral reefs. Both Sentinel and NOAA AVHRR satellites provide this data. Continuous monitoring helps predict and manage bleaching events, protecting the reefs from severe damage. Next, we look at chlorophyll concentration. This measures the amount of chlorophyll in the water, indicating the presence of phytoplankton. High level of chlorophyll can lead to harmful algal bloom that affect coral health. Sentinel-2 and Sentinel-3 satellites provide this valuable data. Water clarity or turbidity refers to the amount of suspended particles in the water. High turbidity can block sunlight, which is essential for coral photosynthesis and growth. Sentinel-2's multispectral imagery help us monitor water clarity and manage sedimentation issues. We move on to the next topic, which is methods to solve issue in coral reef observation. To tackle the issue of resolution and accuracy in coral reef observation using Sentinel and NOAA AVHRR satellites, advanced image processing techniques are indispensable. By leveraging machine learning algorithm and artificial intelligence, we can significantly enhance the resolution of satellite images. One such technique is super resolution imaging, which allows us to achieve higher clarity and detail in coral reef observations. For instance, by employing convolutional neural network, which is CNN, we can process Sentinel and NOAA AVHRR images, thereby improving spatial resolution and accuracy in detecting even the subtle changes in a small-scale reef ecosystem. The second method is multi-temporal and multi-sensor data integration. Cloud cover and atmospheric interference often impede accurate observation of coral reefs. To mitigate these challenges, we employ the method of multi-temporal and multi-sensor data integration. By combining data from different time and sensors, we can fill in gaps caused by cloud cover and atmospheric conditions. This involves utilizing cloud masking algorithm to identify and exclude cloud-covered areas. For instance, integrating cloud-free images from Sentinel-2 with radar data from Sentinel-1, which remains unaffected by clouds, enable us to create comprehensive datasheets that provide a clearer picture of coral reef ecosystem. The third method is integrating multi-source data. Ensuring interoperability and data fusion from various sources is crucial for comprehensive coral reef observation. This method involves developing framework for fusing data from multiple satellite sources along with in situ measurement. By standardizing data format and utilizing interoperable platforms such as the GEOSS, which is Global Earth Observation System of System, we can integrate data from Sentinel, NOAA AVHRR, and other satellite sources seamlessly. This integration enhances our ability to monitor and understand coral reef dynamics effectively.
Assalamualaikum and hi. My name is Shafiq Sikmal, and today I'm going to talk about gap for further study in coral reef observation using Sentinel and NOAA AVHRR. Coral reef are among the most biodiverse and economically valuable ecosystem on the planet, providing habitat for countless marine species and supporting millions of people worldwide. However, this vital ecosystem face numerous challenges including climate change, pollution, and overfishing. To effectively monitor and understand coral reef ecosystem, scientists rely on satellite data from platforms like Sentinel and NOAA AVHRR. Yet, despite the advancement in satellite technology, there are still gaps and challenges in coral reef observation that need to be addressed. First are unsolved problems. One significant challenge is the limitation in data resolution, which can hinder our ability to monitor and comprehend reef ecosystem accurately. High-resolution imagery is essential for capturing fine-scale features and detecting subtle changes in reef health over time. Second are knowledge gaps. Another area of concern is our incomplete understanding of coral reef dynamics and the environmental factors that influence reef health. While satellite-based observation techniques provide valuable insight, there are still gaps in our knowledge regarding the complex interaction between reefs and surrounding environment. Third are methodological gaps. Methodological gaps exist in the analysis of satellite imagery, with flaws or limitations in existing procedures for extracting pertinent information. Developing new and improved method for data analysis is crucial for enhancing our ability to interpret coral reef data accurately. Fourth are technology gaps. Technology gaps also pose challenges with deficiencies in satellite sensor capabilities, data processing processes, and analytical tools. Addressing this gap and leveraging technical breakthroughs could lead to more accurate and comprehensive observation of coral reef ecosystem. Policy and management gaps. Finally, there are policy and management gaps that need to be addressed to ensure effective coral reef protection and preservation. Additional studies are needed to identify areas where current policies and conservation strategies may be insufficient or ineffective, guiding the development of more robust management practices. Despite these challenges, there is hope on the horizon. By addressing these gaps and leveraging the latest advancement in satellite technology, we can better understand, monitor and protect these invaluable marine habitats for generations to come. Second, advanced machine learning for enhanced coral reef monitoring using satellite data. Currently, existing techniques for monitoring coral reef are effective in identifying measuring small-scale variation in reef condition. However, they fall short when it comes to understanding broader reef dynamic. To address this, we propose the development of a new machine learning algorithm tailored specifically for analyzing high-resolution satellite footage from Sentinel and NOAA AVHRR satellite. Our solution involves developing a sophisticated deep learning algorithm, particularly a convolutional neural network or CNN, designed to improve the resolution and precision of satellite data. The key advantages include higher resolution analysis and the ability to detect even the most minor changes in reef health. To ensure effectiveness of our algorithm, we will train and validate it using a diverse dataset. This dataset will include high-resolution satellite image, in situ measurement, and ground truth data collected from various coral reef ecosystems around the world. By doing so, we can continuously improve and optimize the system, enabling it to reliably distinguish between healthy and degraded reef areas and accurately detect coral bleaching episodes. One of the significant challenges in using satellite data is interference caused by cloud and atmospheric conditions. Our algorithm incorporates strategies to mitigate these interferences, enhancing the quality of satellite data. Our algorithm is specifically designed to integrate seamlessly with current satellite data processing pipelines and analytical tools. This integration facilitates easy adoption and implementation by researchers, conservation practitioners, and policymakers engaged in coral reef monitoring and management. By implementing this innovative machine learning algorithm, we aim to significantly enhance our capacity to monitor and evaluate coral reef health using satellite technology. Ultimately, our goal is to protect this invaluable ecosystem for future generations. In conclusion, our advanced machine learning approach holds the potential to revolutionize coral reef monitoring. We look forward to collaborating with stakeholders to implement this solution and make a meaningful impact on coral reef conservation. This is me, Shafiz, and my two friends, Dini and Elise, signing off. Thank you for listening.